opportunity. The ground-based observations are also important. So a combination of the ground-based telescope and the space-based platform is very, very important. And
What we are going to measure with magnetometer is the interplanetary magnetic field that is coming all the way from sun and towards the earth. So typically these values at L1 point are around 5 to 10 nanotesla. But these values increases whenever there is an extreme solar event, such as the coronal mass ejection or say solar magnetic storms. Now these events are crucial to monitor the near Earth space weather, because these can have an effect on the life on Earth. If you remember Quebec, there was an event when the power lines were snapped a few years ago. That was because of an extreme solar event. So to keep an eye on the surroundings of Earth, we need these measurements. And apart from that, for solar wind observations also, these measurements will be crucial. Thank you.
Thank you very much, sir. So now we move on to Dr. Anuj Nandi. So what is the importance of solar flares and the impact in heliospheres? And how does Aditya-L1 contribute to all of this?
Good afternoon, viewers. As my colleagues already pointed out the importance of this mission and the instruments about. So the thing is, as you know, that solar flares are the energetic and explosive energy release in few seconds to minutes time scale, and it is order of 10 to the 27 arcs to 10 to the 32 arcs. Now the thing is, these solar flares, why it is important, as because the solar flares actually tells the dynamics and activity in the sun. So the thing is, there are two unique instruments built by URAO Satellite Center that is going to cover the solar flares from 1 keV to extremely high energy, around 200 keV. And we know that visible sun is only 6000 degree Kelvin temperature, whereas the outer surface of the sun is million degree Kelvin. So the thing is, why there is disparity? So I think these two instruments, along with the other two instruments, VLC and SUIT, we are going to address this $1 million questions, as well as why there is difference. Thank you.
Thank you very much, sir. And now I'd like to go back to Dr. Anil Bharadwaj. So there are many satellites that are sent to the space by other nations. So what makes Aditya-L1 different from these satellites?
Well, that's a very good question, because first of all, let me again tell you that India will be the third, or ISRO will be the third space agency to have a mission at L1 point. And I just mentioned that it is multi-wavelength, multi-instrument, and multi-direction, and it measures particle, field, and radiations. So you don't have such kind of satellites existing at L1 point so far and currently. That makes Aditya-L1 absolutely unique, because we are going to measure remotely, in situ, and particles and fields. I was also mentioning about multi-direction, and that is coming from the aspects payload, which stands for Aditya Solar Wind Particle Experiments. And this is going to measure particles ranging from 100 EVs going to several MeVs, which is essential for us to know, because when the CMEs are happening or the sun is quite angry, the plasma which is coming out from the sun ranges from several EVs to several MeVs. And therefore, we should know in what direction the plasma is coming and whether the plasma is getting accelerated in between when it comes from sun towards earth. And therefore, there is a multi-direction information which is available from the aspects payload, because it consists of two sensors, SWIS and STEP, essentially giving you in two different energy bands. And therefore, we'll be able to quantify the CME, CIRs, and all the processes which is happening on the sun, which gives out coronal mass ejections. Thank you.
Thank you very much, sir, for your remarks. And now finally we move on to the principal scientist, Dr. Sankar Subramaniam. So how does the Indian science community seek to capitalize on ISRO's space capabilities, especially these observatory missions like Astrostat and Aditya-L1?
Yeah, so now ISRO has established that it has a capability to send observatory class missions anywhere in the interplanetary medium. ISRO also is developing capability for small satellite missions like a nanosat, CubeSat, as well as the small satellite capability. And that is something which especially a heliophysics community could utilize it, because we can, at a low cost, we can launch many more such instruments which are essential for heliophysics community here in India. So, and also the bigger mission takes its own life cycle, because it requires technologies to be developed for a bigger missions. So in between these big missions, if we capitalize on these small satellite missions, and that will enhances the science capability of our country to the next level. And as you know, the science and technologies are always synergized. As the technology improves, your science improves. When I started my career in solar physics, I started with a photospheric magnetic field. Now we are in a position where we can do coronal magnetic field with Aditya-L1, which was not feasible when I was doing my PhD. So similarly, as we move on and as the technology starts to improve, we would be able to generate much more capable instruments, much more compact instruments, which will enable us to do much more science than what we can currently do. So we look forward to capitalize on ISRO's capabilities, both at the large scale as well as at the small scale instruments, and also its capability for developing new technologies in the near future.
Thank you very much, sir. That was very interesting. And to end this, I have a last question to Dr. Dipankar Banerjee. And it's about what kinds of outreach is possible through this launch to energize the scientific community?
This is a very, very important question, and we are proud to be Indian now after the Chandrayaan success. I think it's just not the students, it's the entire country is excited. And we got this opportunity to now travel towards sun. So it is very important that the younger generation, comes into the research and also utilizes the data. These scientific missions are for the community, and it has to be the community driven. So some of our scientists, who have been engaged with this mission for decades, we understand what is expected to be, this data. But the younger generation, they need to be trained. And so for that reason, we also have a Aditya support cell at Nainital, and we are going around in the country. We are regularly conducting workshops. So through these workshops and training program, we really want to reach out to other, people who are particularly in the universities or IITs, because they have so far not been directly involved with the Aditya mission. So I think we are really, really going out, and we expect that the youngsters, that the next generation will come and utilize this data, because the data is for the community. So unless, we have more users, we will not be able to effectively utilize the data, scientific data which is coming, and the way we can help the community at large. Thank you.
Thank you very much, sir.
I think it is very important for us also to reach out to schools and colleges, because the younger generation should be told about this kind of activities which is happening in the country. Chandrayaan-3 launch has galvanized the whole nation, and everybody is interested to know what all is happening in the science and technology within the country. And therefore, this mission, along with the Chandrayaan-3 mission, that is the Aditya-L1 mission and Chandrayaan-3 mission, is going to give us a lot of new information which is going to be very beneficial for the country. Thank you very much.
Thank you everybody for participating in this discussion, and now we move on to the control room.
Thank you, Srinidhi, and I thank all the panelists for enlightening us about the high-tech science that Aditya-L1 is about to do.
जी हाँ, अभी आपने सुना इसरो के तथा अन्य संस्थानों के वरिष्ठ वैज्ञानिकों ने हमारे बहुत महत्वपूर्ण सवालों के बहुत ही रोचक उत्तर दिए हैं। इस दौरान चतुर्थ चरण के बर्न 1 को कंफर्म किया गया है फिजी टेलीमेट्री स्थित स्टेशन से। इसमें यान में होने वाले त्वरण के बदलाव को मापा जाता है और इससे पता लगाया जाता है कि यान के इंजन में शुरुआत हुई थी या नहीं, और इसकी पुष्टि कर ली गई है। लेकिन अभी भी यान हमारे दृष्टि से बाहर है, हमारे ट्रैकिंग रेंज से बाहर है, लेकिन इसकी यात्रा अभी जारी है। और अब हम स्क्रीन पर देख पा रहे हैं यह पूर्वानुमानित पथ दिखाया जा रहा है। यह अनुमानित पथ है। ग्राउंड स्टेशन से पुष्टि होने के पश्चात यहाँ पर इसकी पुष्टि की जाएगी। आज 11:50 पर प्रमोचित हुए PSLV-C57 रॉकेट की यात्रा अभी भी जारी है। प्रथम, द्वितीय तथा तृतीय चरण के सामान्य कार्यकाल के पश्चात इन्हें यान से पृथक कर दिया गया था। और फिर
टर्मिनल acquires telemetry signal.
जी हाँ, इसकी पुष्टि हो गई है। शिपबोर्न टर्मिनल से हमारे यान को ट्रैक कर लिया गया है।
At present, ground trace and FPD are updated based on real-time data.
अब हमारे ग्राफ को वास्तविक समय से दिखाया जा रहा है। यह वास्तविक डेटा है जो अब हम देख पा रहे हैं।
Welcome back to the live coverage of PSLV-C57 Aditya-L1 mission. The launch took place at 11:50 hours Indian Standard Time from the second launch pad at Satish Dhawan Space Center, SHAR, Sriharikot. The first, second and third stage of the launch vehicle have performed normally, and the launch vehicle was in the no visibility range for the ground tracking stations. Shipborne terminal in Pacific Ocean has started to acquire signal 51 minutes into the flight.
अब कुछ ही क्षणों में हम चतुर्थ चरण के पुनः प्रज्वलन को देखेंगे।
In the past 26 minutes or so, the ground trace for the flight was being updated by extrapolation.
Fourth stage engine started for band 2.
यहाँ अभी अभी रेंज ऑपरेशन डायरेक्टर ने इसकी पुष्टि की। चतुर्थ चरण का प्रज्वलन शुरू हो चुका है। यह पुनः प्रज्वलन है PS4 का कोस्टिंग फेज के पश्चात। यह वास्तविक समय पे हमें यहाँ आंकड़े उपलब्ध हो रहे हैं क्रूज स्टेशन से।
A very happy
Fourth
piece of
stage
news here.
performance normal.
Range Operations Director has confirmed the second burn commencement for the PS4 stage. around 14 more minutes to go for the spacecraft injection.
जी हाँ, अभी भी लगभग 14 मिनट बाकी हैं हमारे अंतरिक्ष यान आदित्य L1 को अंतक्षेपण के लिए। आपकी जानकारी के लिए बता दें कि इस कालावधि जब अंतरिक्ष यान या हमारा यान हमारी दृष्टि से दूर हो जाता है, इस कालावधि में ग्राउंड स्टेशन की दृष्टि से बाहर जा चुका होता है और यान के ऑन बोर्ड कंप्यूटर पर टेलीमेट्री स्टोरेज पर यान के महत्वपूर्ण आंकड़े सेव किए जाते हैं। जब यह हमारे तय ग्राउंड स्टेशन की रेंज में आते हैं तब इन आंकड़ों का प्रसारण होता है और वहां से इनकी पुष्टि की जाती है कि यान इस दौरान किन गतिविधियों से गुजरा।
Fourth stage performance normal.
The fourth stage performing normally. The second burn is expected to last for 472 seconds.
यह चतुर्थ चरण है PSLV XL रॉकेट का। इसमें 2.5 टन के नोदक का इस्तेमाल हो रहा है। यह तरल नोदक हैं। इसमें 2 इंजन लगे होते हैं, हर एक 7.33 किलो न्यूटन का प्रणोद उत्पन्न करता है। इस तरह कुल प्रणोद 14.6 किलो न्यूटन का होता है।
Plus 55 minutes.
इस प्रज्वलन काल में इसे 472 सेकंड तक प्रज्वलित रखा जाएगा। वरिष्ठ गणमान्य व्यक्ति यहाँ उपस्थित हैं।
We are close to 55 minutes 30 seconds past the launch. PS4 stage currently burning for the second time.
Fourth stage performance normal.
Intended trajectory closely matching the prediction. Presently the shipborne terminal is acquiring the signal. Few seconds later there will be another no visibility phase before Koru starts to acquire signal.
जी अभी द्वितीय बर्न चालू है PS4 स्टेज का। अभी कुछ 200 और सेकेंड जलकर यह शांत हो जाएगा। सूर्य एक बड़ा और हमेशा से एक समीप का सितारा रहा है हमारे लिए। असल में यह गर्म आग का गोला है जो अनगिनत हाइड्रोजन एटम्स के फ्यूजन रिएक्शन से ऊर्जा प्राप्त करता है और इस ऊर्जा से इस सौर मंडल को एक परिवार की भांति समेटे हुए है। पृथ्वी से सूर्य की दूरी लगभग 150 मिलियन किलोमीटर है। सूर्य ही हमारी ऊर्जा स्रोत है और इस जीवन जो हम जानते हैं उसका भी स्रोत है।
Loss of signal for shipborne terminal. The next telemetry station is Kuru. The telemetry signal break will be approximately 205 seconds. During this non-visibility period, ground trace and flight parameters will not be updated.
यान फिर से अंतर्दृष्टि हो चुका है, हमारे ट्रैकिंग रेंज से बाहर है। अगला ट्रैकिंग स्टेशन कुरु स्थित फ्रेंच गयाना स्थित कुरु स्टेशन से हमें आंकड़े उपलब्ध होंगे कुछ ही समय में।
After being injected into the space, the Aditya-L1 will not travel directly to the L1 point. Transfer maneuvers will be performed to position the spacecraft in a halo orbit. Aditya-L1 will first be made to perform maneuvers in Earth orbit. Adjustments will be made in its orbital parameters. After ascertaining the normalcy of the craft, its systems, payloads, and the orbital parameters, burn to exit Earth's sphere of influence will be initiated. After exit from SOI, the cruise phase will start, and subsequently the spacecraft will be injected into a large halo orbit along L1. The total travel time from launch to L1 will take about 4 months for Aditya-L1.
इस दौरान आइए आपको अवगत करा दें आदित्य-L1 के मुख्य उद्देश्य से। आदित्य-L1 मिशन का मुख्य उद्देश्य है सौर गतिविधियों के विभिन्न पहलुओं में महत्वपूर्ण जानकारियां उपलब्ध कराना और इन गतिविधियों का अंतरिक्ष मौसम के असर का अध्ययन करना। इस कार्य के लिए इसमें 7 भार लगे हुए हैं, जिनकी मदद से आदित्य-L1 फोटोस्फीयर, क्रोमोस्फीयर और सूर्य के बाहरी परत के विभिन्न वेवलेंथ में प्रेक्षण कर सकेगा। विशेष वैज्ञानिक उद्देश्य इस प्रकार हैं: सूर्य के ऊपरी परत, जिसे हम कोरोना के नाम से जानते हैं, इसकी गतिकी का अध्ययन करना, क्रोमोस्फीयर और कोरोनल तापमान, आंशिक रूप से आयनिक प्लाज्मा की भौतिकी, कोरोनल मास इजेक्शन की शुरुआत और फ्लेयर्स का अध्ययन, सूर्य के कण की गतिशीलता के अध्ययन के लिए आंखें प्रदान करना और यथास्थिति कण और प्लाज्मा वातावरण के प्रेक्षण करना।
+1 hour.
वर्तमान में आरओडी ने घोषणा की अब चतुर्थ चरण को बंद कर दिया गया है, अब उसका थ्रस्ट कट ऑफ कर दिया गया है और वह बंद हो चुका है और इसकी भी पुष्टि हो चुकी है कि आदित्य-L1 के अंतःक्षेपण की स्थितियां प्राप्त की जा चुकी हैं।
We are now eagerly awaiting the injection of the satellite, as we have the confirmation from the Range Operations Director that the thrust cutoff for 4th stage of PSLV has been achieved. We are 1 hour into the flight.
कुछ ही क्षणों में क्रूज स्थित ग्राउंड स्टेशन से इसकी पुष्टि की जाएगी।
Highly anticipated event next is the separation event of Aditya-L1 spacecraft.
यान अपने निर्धारित कक्षा की ओर कुछ ही क्षणों में इसकी पुष्टि होनी बाकी है। यान से अंतरिक्ष यान आदित्य-L1 का सफलतापूर्ण अंतःक्षेपण अभी बाकी है।
For Aditya-L1, ISRO has developed advanced flight dynamic software to obtain past trajectory data from tracking, apply mathematical computation to calculate present and future location of the spacecraft, in a process known as orbit determination. But the correct orbital parameters at the time of injection are of prime importance.
अब तक कुल 22 सौर मिशनों को नासा, ईसा, जर्मन
Aditya-L1 satellite separated.
और जिसका इंतजार था वह पल आ चुका है, इसकी पुष्टि कर दी गई है।
PSLV-C57,
आदित्य-L1
Aditya-L1 mission accomplished. Handing over to mission director.
And we have a confirmation of Aditya-L1 separation. The mission has been accomplished.
PSLV-C57 has injected Aditya-L1 satellite into the desired intermediate orbit. PSLV-C57 Aditya-L1 mission is accomplished.
आदित्य-L1 को पूर्ण परिशुद्धता से इसके निर्धारित कक्षा में स्थापित कर दिया गया है। इसके बाद वह अपने आगे की सफर जारी रखेगा L1 पॉइंट के लिए।
Do join us for the address by Chairman ISRO Secretary Department of Space Shri S. Somnath.
सभी दर्शकों को शुभकामनाएं और बधाइयां इस मिशन की सफलता के लिए। अब हम आपको लिए चलते हैं अध्यक्ष महोदय के एड्रेसिंग के लिए।
Congratulations. The Aditya-L1 spacecraft has been injected in an elliptical orbit of 235 by 19,500 kilometers, which is intended very precisely by the PSLV, very unique mission mode here, with the upper stage of the PSLV taking 2 burn sequence for injecting the primary satellite for the first time. So I want to congratulate PSLV for such a very different mission approach today to do this mission of Aditya-L1 to put it in the right orbit. Now, from now, the Aditya-L1 will take its journey after some Earth maneuvers. It will start its journey to the L1 point, a very long journey of almost 125 days. So let us wish all the very best to Aditya spacecraft for its long journey and being put around the halo orbit of L1. So with me, the mission executives are there. Mr. Biju, the mission director, and Nigar Shahji, the director of the satellite project. So let them join me. Our Honorable Minister of State for Science, Technology and Space is here, Dr. Jitendra Singh. So I request him to speak a few words.
Congratulations, India. Congratulations, ISRO. And while the whole world watched this with bated breath, it is indeed a sunshine moment for India. Thank you, Honorable Prime Minister Narendra Modi ji, for making this happen by opening up new vistas for India's space sector and telling us that sky is not the limit. Thanks also, Honorable PM, for giving us the confidence, the courage and the conviction to reach out to the stars and to discover the mysteries of universe beyond. And thanks also for making us realize the enormous potential of our space fraternity. Ladies and gentlemen, Indian scientists had been working, toiling day and night for years and years together, but now comes the moment of vindication, the moment of redeeming the pledge to the nation. And coming close on the heels of successful Chandrayaan-3 landing, the successful launch of Aditya-L1 is also a testimony to the whole of science and a whole of nation approach which we have sought to adopt in our work culture. While ISRO is credited in executing this mission, the science institutes across the country have come forward to contribute in one form or the other, in small measure or big, to this mission. To name a few, the Indian Institute of Astrophysics, Bengaluru, the National Aerospace Laboratories, the Tata Institute of Fundamental Research, Mumbai, the Nijri NGRI, Nagpur, the IIT Kharagpur, IIT Madras, IIT Delhi, IIT Mumbai, and the list is too long. But that, having said that, gives me the confidence to say that this day, the 2nd of September 2023, is a day of reckoning when we move on into the next 25 years of Amrit Kal, and Mother India pledges with the collective will and collective effort of our 140 crore children to reach and occupy the place of pride on the world pedestal. Congratulations once again, Chairman Somanath, the entire ISRO team, and the entire countrymen.
May I request the Project Director of Aditya-L1, Nigar Shaji, to say a few words.
Good afternoon. It's a dream come true for Team Aditya-L1, and I'm extremely happy that Aditya-L1 is injected in the intended orbit flawlessly by PSLV as always. And Aditya-L1 solar panels are deployed, and the spacecraft will be normal. And Aditya-L1 has started its 125 days of long journey towards L1. We have our Earth burns to rise the orbit, and followed by the trans-L1 injection, and finally insertion into the halo orbit in the Sun-Earth Lagrange point L1. Once the Aditya is commissioned, it will be an asset to the heliophysics of the country and even to the global scientific fraternity. And I take this opportunity to thank Chairman ISRO, Director URSC, former Director URSC, and all the Center Directors for their support and guidance for making this mission possible. And my thanks are due to my project team and all the project executives across the center, payload teams, especially the teams from the IAA and IUCA, for the relentless effort in building the payload as well as the spacecraft. And my special thanks to the expert committee who have been guiding all through the entire project life cycle. And I thank all the industrial partners and the entire URSC team for their invaluable contribution. And I feel really honored and privileged to be part of this mission. And at this juncture, I would like to remember Professor U.R. Rao, who sowed the seed for this mission, and looking forward for a successful halo orbit insertion and further great science output from the Aditya-L1 mission. Thank you all.
Sri Biju, the Mission Director and the Project Director of PSLV.
Good afternoon to all. My big salute to all of you for achieving this wonderful mission of Aditya. We have injected Aditya in its intermediate orbit. PSLV in its 59th mission has successfully accomplished injecting Aditya-L1 in its intermediate orbit. It's all because of the dedicated effort of all of you. The challenging requirements given by satellite team was indeed very it was very challenging to meet the orbital requirements. We have gone for a new mission design strategy. We have gone through numerous simulations to validate this, and that is the proof that you are having now. I take this opportunity to thank each and every one of you for achieving this wonderful mission. I take this opportunity to thank all my review forums, chairman and members of all review forums, and our industry partners for giving high reliable systems for PSLV, and all our family members. With this, our capability of PSLV has increased manifold to venture into new missions, to new and challenging missions. I take this opportunity to thank my project team led by our Sri M.J. Lal as well as Damodaran, Vehicle Director and Associate Vehicle Director, in leading the entire campaign. I wish our satellite team
an excellent time ahead for completing all the operations and completing all scientific objectives they have envisaged. Thank you all. Thank you very much.
Thank you everybody for spending your time watching this mission and also supporting us and congratulating us, and we joined the entire country. We are very proud of the fact that we could do this mission, Aditya-L1 mission, just following the Chandrayaan-3 activities, and all of you are aware that the lander and the rover are still functioning, and our team is with the scientific instruments doing a lot of work now. And the good news is that the rover has moved almost 100 meters from the lander, and we are going to start the process of making both of them sleep in the coming 1 or 2 days, because it has to withstand the night. So until we hear about them later, so I would like to say big thanks to each one of you for the support and encouragement and blessings that you are giving to us for continuing the work of building the very strong space infrastructure and capability for India, and which will be becoming one of the strong pillars of science and technology for this nation. And thank you so much for the contributions once again, and wish you all the best for meeting you for next mission from Satish Dhawan Space Center. Thank you.